All right, we're going to solve one-step equations. One-step equations, just as the name implies, you'll be able to solve after one step. But before we get into the actual equations that we'll be solving, let's take a look at what the actual ultimate goal of solving equations is. Okay? We ultimately want to get our variable on one side with no coefficients. So we want that one variable, our final answer should look something along the lines of x equals some number. Okay, x equals some number. Okay. Now we'll perform we'll isolate that variable by performing inverse operations. Okay, addition and subtraction are inverses, and multiplication and division are inverses. When we work with the inverses of addition and subtraction, we are trying to make a 0, okay? And when we're dealing with the inverses of multiplication and division, we are trying to make a 1, okay? A 1. So that's what we're trying to do. And we're starting here with the most basic, and we'll get into some pretty tough equations here this year, but we will start with the basics. And as you'll see, as we get into more difficult ones, everything will come back to these inverse operations. A couple of examples here. Let's take a look at the left one first. X minus 3 equals 15. Now we are trying to get this x right here by itself. Okay? So in order to do that, we can't work with it yet. It's the last thing we would work with, so we ignore it. So right now we have x minus 3. The inverse of minus 3 is plus 3. So I'll add 3 on this left side. And then I'll add 3 on the right side. Okay? Ultimate, one of the most important rules in equations is if I do something on one side, the left side here, I also have to do it on the right side. So if we look here, I have negative 3 plus 3. Well, that gives me 0 equals 18. Well, we just learned about the identity property of addition. X plus 0 is just x, and that equals 18. As we do more and more equations, you won't even have to show this x plus 0. You'll go straight from plus 3 on both sides to x equals 18. Okay? Our second example here on the right, x plus 6 equals 15. Now again, we are still trying to isolate this variable, the x. So we can't do anything with it yet, but we have to work on that side. In order to get rid of that plus 6, we need the inverse of adding 6, and that is subtracting 6. So I'll subtract 6 from both sides. Now when I do that, I have positive 6 minus 6. Those cancel out and give me 0. Again, this you won't necessarily have to show. 15 minus 6 equals 9. Anything added to 0 remains itself, so we ultimately end up with x equals 9. Okay? Two basic one-step equations by adding and subtracting. Now again, still going to be about one step, but there's going to be a little setup here first with these ones. Again, we're trying to isolate our x. Now with that x right now, we have a minus a negative. Minus a negative, we always want to go through and change to plus, positive. Okay, taking away a negative is the same as adding a positive. From here, this equation is the same as the two that we just did. I have x plus 4. The inverse of adding 4 is subtracting 4. I will subtract 4 from both sides. Negative 8 minus 4 is negative 12. Since these cancel, I can just write that that equals x. That's how you would see it when you don't put that plus 0 in there. Okay? Subtracting 4 is the inverse of adding 4. That's why we did that. Hopefully that helps you there. If we take a look at the second example, you can even pause and try it on your own first. I have minus negative 2, so I'm going to change that directly to plus positive 2. And from here, the inverse of adding 2 is subtracting 2. And I will do that on both sides. Negative 11 minus 2 is negative 13. And that is equal to, these positive 2 and negative 2 cancel out, make 0. I get x equals negative 13. And again, that minus 2 is the inverse of adding 2. Our last example today is a word problem. Basic, but again, it'll be good practice for us to see what we just learned in an applied problem. So let's take a look here. Your bank balance is $42. Okay? Important information. If you write a check to buy a pair of shoes, your balance would be negative $5, which obviously would not be good because your check would bounce. Okay? How much do those shoes cost? All right? It says write and solve an equation that models this situation. So I let x equal the cost of shoes. Okay? Because that is right here. How much do the shoes cost? All right? So now, if we start with $42, I start with 42. When you buy something, you take money away from you and give it to whoever you're buying from. So I'm going to take my $42 and I'm going to subtract x, which is the cost of the shoes. When that happens, that means that the balance of my account is negative 5. Okay? So there's our equation. Now we have to solve it. And we're actually going to have a second step here, but let's take a look. Right now I have my x and I have a positive 42. The inverse of positive 42 is negative 42. So I subtract 42 from both sides. 42 minus 42, that's 0. I'm left with the opposite of x is equal to negative 5 minus 42 is negative $47. But we can never have a negative in front of the x. So what we have to do if that happens, we have to divide everything by negative 1 because it won't change. It'll just cancel out the negative. So we get x is equal to positive 47. So the cost of those shoes is $47.